All right, welcome back to Introduction to Wireless Communications. I'm Sundeep Rangan at New York University. So we've been talking a lot about fading in Unit 3. We talked about the physical basis for fading, and in Unit 4, we talked about the effect of fading on coded modulation. In this unit, we're going to step one layer higher in the protocol stack at the MAC layer and look at a very important part of designing real wireless systems, which is adaptive modulation and coding. So the idea is this: we know from a physical basis that fading can cause variations in the SNR, like I've shown here on the right. And what that means for coded transmission over faded channels is that you will have periods where the rate is very high and then other periods where the rate is very low because the channel can go into a deep fade. Now, what this means at the MAC layer is that the transmitter has to select the correct modulation and coding scheme to adapt to those channel variations. And that raises several basic questions which we're going to try to look at in this unit. The first is, how does the transmitter select that modulation and coding scheme? What kind of information does it need back from the receiver of the channel, and what does it do with that information? After it is selected the modulation and coding scheme, we have to look at how it actually transmits that modulation and coding scheme to the receiver in a reliable manner. And that sounds easy, but actually there are a lot of things you need to get right to make this system work. And then finally, you'll always invariably have errors that partially result from selecting the incorrect MCS, and we need to figure out how to design protocols that can overcome those errors. So I think the best way to understand these higher layer protocols is by example with real systems. So with that in mind, we're going to start looking at what's called the ARQ protocol in the 802.11 systems. And by the end of this, you'll be able to implement and simulate at least a pretty simple trial and error MCS selection system for these kind of wireless LAN systems. We're going to then look at really state-of-the-art cellular systems. These are a little bit more complicated, but we're going to break it down bit by bit, and we'll really be able to understand what happens packet by packet, time slot by time slot in these kind of systems. Now, these systems also have a very sophisticated way to measure the channel quality and feed that back to the transmitter. And we're going to actually show you how to implement that type of measurement system and make pretty good quality measurement systems with just a little bit of math and some pretty simple algorithms. And you'll be able to implement that and actually put that in to your own simulation. Another aspect of cellular systems, they have a super powerful tool called Hybrid ARQ. We're going to walk through that and show you the key steps of how these Hybrid ARQ systems are built. And you're going to be able to put all of this together. So by the end of this unit, you will hopefully be able to implement and simulate a real multi-process Hybrid ARQ system over a faded channel using some of the amazing tools that come from the MATLAB 5G toolbox. So with that in mind, let's get the unit started, and you can go to the next section.